Greetings and welcome, mis amigos. We're talking about solving systems using probably Devin and my favorite, the system solving capable elimination method, which just completely destroys coefficients in front of variables. It's great because notice for this problem 12, there is no weak spot. I think you guys agree. So step one of the elimination method was multiply one or both of the equations by a constant, which just means a number, such that you will have opposite coefficients for one of the variables. So I'd want those to be opposite or these to be opposite. Okay, so between 4 and 8, what do both 4 and 8 go into? 8. They both fit into 8. 8 fits into itself, yeah. 16 is the next highest. You're not wrong if you use 16. You'll still get the same answer. You just have a little bit bigger numbers. What do 5 and 3 both go into? 15. So let's pick the 8. So I don't have to multiply this equation by anything to get an 8x. It already has it. What would I have to multiply this equation by? 2. And because I want them to be opposite coefficients, let's make that a negative 2. All right, so step one. Let's do this. So negative 2 times 4x is negative 8x. Negative 2 times negative 3y is plus 6y. And don't forget the right-hand side. Negative 2 times 5 is negative 10. 10. So that is, I think, the trickiest step for the elimination method. But once it's done, this is the benefit. When I add them together in step 2, which I'll rewrite this just for funsies so there's, kind of right next to each other. Oh, this one's going to solve real nice. Real nice. Notice what happens when I add these down. Eliminated. Right, those get destroyed because they had those opposite coefficients. How convenient. Let's see, 6y minus 5y. How many y's is that? It's just one y. We can call that y. And negative 10 plus 11 is the same as 11 minus 10, which is 1. So I get y equals 1. Normally, sometimes you'll have a little bit of solving to do, but step 3 is kind of already done there. Step 4, what do I do, Ethan? Yeah. Yeah, this is only half of our answer, so where would you want to put this? Which equation do you like, Ethan? Where would you want to plug 1? The top one? All right, we'll do the top one. I would have picked the second one because these are smaller numbers, but it literally does not matter. It'll work either way. So 4 times x minus 3 times 1 instead of y. No, guys, I'm plugging it into the wrong one. The thing I said whatever. Here we go. 8x minus 5 times 1 equals 11. I didn't want to just be like facetious and be like, yeah, I'll plug it into the one you told me to, and then just completely not do that. That'd be kind of rude. That'd be kind of rude. So let's see. So let's solve this. 8x minus 5 equals 11. Oh, we are experts at solving this. Let's add 5 to both sides. Right. 8x equals 16. And then divide both sides by 8. And so even if you chose to solve for slightly different variables, even if you chose to eliminate different variables at the beginning, you still should get the same solution of, why did I say y here? Yeah, you almost caught my mistake before I did. Almost. So yeah, so we would have 2 comma 1 is the solution. Even if we chose to solve this using substitution, here, let's pay attention and don't get distracted by our supposedly non-distracting fidgets. Even if I chose to solve this by substitution, I'd get the same answer, except substitution, bad news would be, I would have created so many fractions to use substitution here. Question, comment? Yeah. All right. Here's question 14. Step 1. We are going to try to get these opposite coefficients here. So what do 10 and 2 go into? 10. What do 9 and 3 go into? 9. Let's go with the 9. It's smaller. I don't have to multiply this one by anything to get that to be a 9 or a negative 9. So this one's done. That's nice. That's nice of them. What would I have to multiply 3 by to get 9? 3. So I'm going to multiply this entire equation by 3. All right, this is step 1. I'll tell you the words for step 1. Multiply one or both equations by a constant in order to get opposite coefficients for one of your variables. Lots of words in that, but that's okay. So let's see, 3 times negative 2x is negative 6x, 3 times 3y is 90, and 3 times 10 is 30. And step 2, the benefit of this is that when I add these together, I'll have one of those variables get eliminated. I'll rewrite the top one just one more time. You don't have to, but it might not be a bad idea. Sometimes you can make mistakes. So let's add them up. Negative 6x and 10x is how many x's? Yeah, positive 4x's. Notice, oh, this is wonderful. Those y's, swipe, those done get canceled. Equals 76. All right, step 3 is solve this. How do I solve that for x? Yeah, divide both sides by 4. I'm guessing that's 19. Is that 19? Nice. Notice the benefit of eliminating one of the variables is I'm left with an equation with only one variable type. And we are really good at solving those. Let's see, and then step 4, if I want to find y now, where would I put this? Yeah, I like this second equation. It's got smaller numbers. And rip. And I'll plug it in for the x part there. So the negative 2 will still be here. So negative 2 times 19 plus 3y is equal to 10. So that's negative 38 plus 3y equals 10. And we know how to solve these too, right? I would, actually, you guys tell me, what should I do? Yeah, I did that, yep. Yeah, I'm going to move that 38. And that actually is a like term with 10. So I'll have 3y equals 48. Ooh, I think I know this one, guys. Divide, yep. And we're getting so good at solving. I'm telling you guys, you might not realize it, but you've been growing stronger every day. Wonderful. I believe that's 16. So my solution is 19, 16. Guys, don't get distracted by our fidgets. That's actually harmful to our education. So let's see. Then I gave you a couple more problems. I'm going to do one of them, where instead of having you solve it, I just was more interested in what would your step 1 have been, okay? So let's see. Let's look between 12 and 8, all right? What would I multiply each equation by to get opposite coefficients? So let's do this way. 8, 16, 24, 36, 48. And yeah, if I do 12s, 12, 24, yeah, you're right. 24 is the least common multiple. That's the mathy word for that. And how about 7 and 11? Yeah, I have a feeling. The way I know that is that these are both what are called prime numbers. And yeah, if I make the list, it's not going to happen until we hit 77 for that. And so if I have a choice, which one do I want to work with? Yeah, 24 is way cooler. So I would multiply the first equation by what? 2, yep. 2 times 12 is 24. 8 times what is 24? 3. And I need one of these to be opposite of the other. So yeah, you can make the 2 negative, you can make the 3 negative. Either of those would be perfectly legitimate. So that's all you had to do for that problem. So thank you for watching. Have a great day, Internet friends. Bye-bye.